All right, so let's look into some final optimizations that we can do here. And like I said, we can change the icon, and we can also change the title as it is displayed in the game window. And there was one more thing. Yeah, you may have noticed, or you will probably have noticed, very likely, that in this video, it kind of looks a little odd and is not very easy on the eye when the obstacles move in the game. And that is simply because I record at a lower frame rate as the game. I mean, the game, it is rendered at 60 frames per second, if it can achieve that. And I recorded at 30 frames per second, and that mismatch kind of makes it odd looking in the final render of the video. But in the actual game, it looks fine. But there is an optimization that we can do here. First of all, we can enable VSync, vertical synchronization. And what that does is it synchronizes the refresh rate of the monitor of the screen with the draw calls that it makes to the graphics device. And long story short, what we can do here is an optimization, but it's just very minor. But what we can do here is, in our initialize method, we could do something like graphics synchronize with vertical retrace and set it to true. So this is a property of the graphics device manager class. And this way we can enable VSync to synchronize the refresh rate of the monitor with the draw calls. And this really depends on your hardware. So if setting this to true, this is synchronized with vertical retrace property, if this causes problems for you on your machine, then simply just don't do that. But for me, I think this should work because I'm working on a modern and powerful machine. So yeah, and there's one more thing that we can do to optimize rendering pixel graphics, and that is in our draw method of the TrexRunner game class here. When we call the begin method of the sprite batch, we can basically tell it how to handle textures. Let me just see here. So as you can see here, there's one overload of the begin method where all of the parameters are optional. And one of them is the sampler state parameter. And we're going to use that. And we're going to pass a predefined sampler state named point clamp. And yeah, a short description of what this does, it basically makes sure that, for example, if I were to say, okay, we want to render, basically make sure that the positioning of the texture coordinates is always snapped to pixels. And it doesn't move in like subpixel areas. So that's just a slight optimization that we can do. If you run the game now, you will probably not notice much of a difference, especially since it's a recording. But it might actually make the movement of the obstacles look a little bit smoother and less blocky and easier on the eye. But it's just a very slight optimization, and you might not even notice a difference. Like I said, it also really depends on the hardware and stuff like that. But let's go ahead and let's actually change the title of the game. So currently it simply displays TrexRunner spelled in one word, but we don't want that. Let's see. And I haven't done that in a while. I think we should be able to, yeah, here. There's a window property of the game class. So it is a property that we inherited from the game class, and that game window class has a title property, and I think we can use that to set the title. And it is probably best to set that in the initialize method. We could also do it in the constructor, I think, but let's use the initialize method for that. So first of all, what I'm going to do is create a constant here, and actually I'm going to make that public. It's going to be a public constant string named game title, and let's call the game TrexRunner. Call it whatever you want. Be creative. I'm just going to be very dull and boring, and I'm just going to name it TrexRunner, but not spelled as one word. Here in the initialize method, I'm going to say window title equals game title. There we go. And if I run it now, it should display the title correctly. Yes, it does. Perfect. There we go. And what else? Yeah, the icon. We could also change the icon. Currently, it uses the default MonoGame logo. We could leave it like that, but maybe we want to create our own icon. So yeah, I'm going to whip up an icon really quick. I think I'm just going to use this here as the icon. That should be fine. Just give me a minute to create that icon file. Okay, so all I did here is I cropped that specific sprite here into a new image, and I think that photo filter actually has a feature for exporting images as icons. The save as, there it doesn't work, but I think there. I can just export that as an icon. And oh, 48 by 48, and I really don't want to rescale. So currently it's at 46 by 46, so maybe let me just adjust that. There. Yeah, that should be fine. And tools, export. And I'm just going to make this icon file available to you. I'm just going to put a link in the description or add it to my GitHub repository, something like that. So if you don't want to create your own, you can simply use this. There, let's call it T-Rex icon. There. And now I'm going to go back into Visual Studio, and I can simply set the new icon by right-clicking the project and going to Properties. And then here in the Application tab, I can simply set the icon down here, click Browse, go to the folder I just put the file into. There it is. And there we go. Hit Control S to save. And now if I start it up again, it should actually use the new icon. Yep, there we go. I mean, it looks a little silly that it uses the same sprite, but whatever. Feel free to create your own icon. Yeah, you just need to make sure that it's an ICO file. But you can, you should be able to just use any PNG or JPEG file and convert it to an ICO file with some online converter tool. There should be plenty of them out there. So yeah, that's great. And I guess now that we created our own icon, we can remove this default icon that was included in the project template. I'm just simply going to go here. So this is the icon.ico. which is the MonoGame logo. And I'm just going to delete that. Yes. Start it up again. There. Okay. So what else? Icon has been replaced. Window title has been adjusted. Yeah, maybe one more thing. Let me run into that. And you just noticed that the high score wasn't, or you may have noticed that the high score wasn't shown a second ago, and that was because between cuts, I simply deleted the build, the debug build. So this is a completely new build of the game. So the save file wasn't available yet. But now when I run it, it should actually show the high score again. There we go. So the only reason it was deleted was because I actually deleted it myself. Okay, so yeah, there we go. And yeah, one more thing is that I want to be able to reset the high score actually from within the game, so that you don't have to manually delete the save file. So what we're going to do is, let's say if the user presses, let's say F8, if the user presses the F8 button, then the high score gets reset. So let's go into the update method. Whoops. There. And I guess we could go basically anywhere here. Let's say if keyboard state is key down keys F8 and previous keyboard state is key down F8. Whoops. Oh. There, but negate that. So if the F8 key is pressed in this frame, but it wasn't pressed in the previous frame, and I think this, wait, no, that should be fine. Yeah. Yeah, okay. So if the F8 key was not pressed in the previous frame, but it is pressed now, then we want to reset the high score. And I guess we can do that by simply saying scoreboard dot, well, let's encapsulate that in a method. I'm going to go all the way down here. Why did I make these two methods public? Well, it doesn't really matter. Let's call it reset save state. And what that's going to do is well, actually, it's simply going to set the high score property of the scoreboard to 0 and set the high score date to the default value of date time. And then it'll call the save game method to actually save that to the hard drive. And then here in the update method, where is it? Here. If the F8 key is pressed, I'm going to simply call that method, reset save state. There. So now I'm going to start up the game again. There we go. High score is 90. Let me break that high score, set a new one, just for kicks. Oh no! no, I lost the game. But I set a new high score, 154. And now restart the game. And now I'm going to press F8. And the high score disappears. And when I close the game now and run it again, yeah, the high score is still gone because we've overwritten the save file. Now I set a new high score. Press F8, it's gone again. And let me just make sure that we can save a new file, a new high score file here. 34, close, start it up again. And there we go. Yep. So now we have some sort of debug functionality, or yeah, you may not even consider this a debug functionality. Really what we have here now is a function of the game to, yeah, reset the high score. And I guess that's it. Yeah, I just thought of one more slight enhancement, or actually it's a pretty cool enhancement that we can do. And that is that maybe we could add a feature or the ability to increase the size of the game window. So currently it is at a fixed size, and it is the dimensions of this window is actually identical to yeah, the width and height of the original game. But I figured it would be a good idea to give the user or the player the possibility to double the size of the screen or of the window just by a simple button press, so that maybe people who have trouble seeing this or just maybe want to experience it in a larger window, yeah, they can just hit a button and enlarge this. And yeah, that's what we're going to do now. And yeah, there's a very simple way we can achieve this. We can manipulate the sprite batch and the way things are rendered using a transformation matrix. So here in the draw method, in the begin method of the sprite batch, we can actually pass an instance of matrix here for the transform matrix parameter. If you don't pass anything, it is null by default. But you can use this to manipulate how the positioning and the scale and whatnot of everything that is rendered. So we don't have to mess with the actual positioning values and the scale of the actual sprites and stuff. Everything will be the same, but before stuff gets rendered to the screen, this transform matrix will be applied, and we can simply calculate and create our own matrix and pass that to the begin method. So let's go ahead and do that. Maybe let's I'm going to create a nested enum here. Whoops. And I'm going to call it display mode. And there will be two display modes, default and zoomed. And zoomed will simply be, if the display mode is zoomed, then the window will be double the size. Okay, so let's create a property here. Of that type, display mode. And we can't name it display mode since the nested class here is already named display mode. So I'm going to name it window display mode. and I'm going to initialize it with the value default, even though I technically don't need to do that. There we go. And let's see. I guess that's fine. I'm going to add a new method all the way down here. It's going to be private, and let's call it toggle display mode. And I'm going to say if display mode equals default, then the obviously I meant window display mode. So if the current window display mode is default, then we'll switch to zoomed. And otherwise, obviously we're going to do the exact opposite. Like this. And obviously there is some more logic required here. So first of all, what we're going to do is we need to set these values here. The preferred back buffer height and width of the graphics device manager. So let me just copy this here. Oops. Sorry, I'm not currently using a mouse, I'm using the touchpad. So sometimes I mess that up. So let's go here. So if we change to zoomed, obviously we want to multiply the height and the width by 2. And if we change to default, then we just use the height and width directly. And then down here, we want to apply the changes like this. And now we also need to calculate the transform matrix to use for our sprite batch. And let me actually define this as a constant because we're going to use it again. So let me just go here and say private integer, private constant integer, say display zoom, zoom factor, which is 2. And then here I'm going to change this to this. There we go. So we increase the size of the preferred back buffer height and width like this, and then apply the changes. And now we need to also calculate the matrix. Let's see. Yeah, I guess we can simply, should we? Yeah, let's go all the way up here to the field declarations. Let's add a new field of type matrix, and let's call it transform matrix. And we will initialize it with the identity matrix, which is basically the default matrix that is used if we don't specify any for the transform matrix. Yeah, and in the begin method of the sprite batch, we're simply going to, oh, whoops, pass that as the transform matrix argument there. So if we start it up now, we will simply always use the identity matrix, which should not make any difference. See, everything still looks exactly the same as it did before. So yeah, obviously we don't just always want to pass this identity matrix here. Instead, when we toggle the display mode, we want to change that matrix. So here, when we switch from default to zoomed, we're going to set the transform matrix to matrix.identity and then multiply that. Let me just here. Multiply that by a scale matrix. There. This should work, right? Yeah. So we can create a scale matrix here by simply using the create scale method of the matrix struct. And for the x scale argument, we pass the display zoom factor, and we also do that for the y scale argument, but not for the z scale argument, because we do not want to scale in the z direction, because there is no z direction. It's a two-dimensional game. So there we go. And yeah, when we change back to default display mode, we simply want to set the matrix back to the identity matrix. There we go. And that's it. And now we just need to define a key that needs to be pressed to actually call this toggle display mode method. And I think let's go with F2 maybe, or F12. Yeah, could be anything really. Yeah, let's go with F12. Here in the update method, we're going to do a similar thing as we did here. Let me actually just copy this and change the key to F12. Oops, F12. And then instead of calling the reset save state method, we're going to call the toggle display mode method. And this should already do the job. Let's see. I'm going to go ahead and press F12. And it's all zoomed in. Great. Let me see if the game still works as expected, if everything is positioned right, and the collision detection works and stuff, but I don't see a reason why it wouldn't work anymore. What I just thought about was that we kind of affected the spawn rate of the obstacles because we changed the speed at which the score increases. So let me just fix that. Let me go back into the obstacle manager here and maybe adjust these values a little bit. So here the obstacle distance is actually measured in points. So maybe let's go down to 8 and 40. Let me test that. I'm going to go down to maybe 30. And I'm going to also change the min spawn distance to 10. But you can really adjust these values to whatever you think is appropriate. Going down to 6 here, and maybe here 28, and yeah. I'll just keep it like this. I'll leave it up to you to come up with some values that feel right to you. But I just played it for a while. I ranked up, I think, 3,300 points, and yeah, it felt quite all right. Okay, so I guess that's it. And let me just check again here if at any point in time we can switch the game mode. I mean the display mode. But it seems like that is not a problem. Every time I hit F12, we switch from regular display mode to zoomed display mode, back and forth, and it works just fine. Except the button no longer works here. That one I didn't see coming. And that is because the mouse position, we check the mouse position if it's within the boundaries of the button. And since it's zoomed in now, those coordinates no longer match with the mouse coordinates. If I go to regular display mode again, then I should be able to click it. That's a little bit of a problem, but we can fix that very easily. Everything else should not be affected since it doesn't require checking for the mouse position. So the problem is here that basically we check for hard-coded values. So let's say the coordinates are, I don't know, x 80 and y 50. Then in regular display mode, the coordinates actually match, but if we zoom in, then x 80 and y 50 is somewhere here. Yeah, I just clicked there and the game restarted. So yeah, we need to fix that, obviously. So let's go into the game over screen class. And here in the button bounds property, we need to actually factor in the current display mode. And we do have an instance of game available as a field, and we can use that. But first of all, let me go back into the TrexRunner game class. And here, let me make the display zoom factor constant public. There. And then I go back into the game over screen class. And here we're going to simply factor in the zoom factor. So let's see. The position is the button position to point. Can we just multiply that? I guess so. So let's go here and say multiplied by, then game display mode, window display mode equals default. Then we multiply by 1. Otherwise, we multiply by TrexRunner game dot display zoom factor. Right? But I need to put this in parentheses. There. What's wrong here? Well, apparently, I thought the point struct had an overload for the multiplication operator, but apparently it doesn't. But I think the vector does. Well, anyway. Let me just check something here. I think the vector2 struct actually has an overload for the multiplication operator, but you can pass a float. And then you can simply call the 2-point method. Yeah. There, multiplies the components of vector by a scalar. So here, instead of multiplying it by 5, obviously what I want to multiply it by is either 1 or 2, depending on the current display mode. So game, or actually maybe, let's make it even easier. Let's go into the TrexRunner game class. And down here, I'm simply going to add a new property of type float. And let's call it zoom factor. And it's going to return if the current window display mode is default, then it's going to return 1, and otherwise it's going to return the display zoom factor constant, which is 2. And then I can simply use this property in the game over screen to multiply the position by. There. And I guess I also have to do that for the width and the height of the rectangle, because it's now double the size. And since this is a point, it expects 2 integers, so I'm just going to simply cast that to an integer. It might be actually more accurate to first multiply this and then cast the result to an integer. There. There. Let me maybe format this a little bit. Actually, that's fine. There. So instead of using the button position directly, I'm multiplying it by the zoom factor, which is either 1 or 2, depending on the current display mode. Then convert that to a point using the 2-point method. And for the width and height of the rectangle, I'm going to create a new instance of point, and I'm multiplying the width and the height of the button sprite with the current zoom factor. Simple as that. And now when we start up the game again and toggle to the zoomed display mode there, and now run into an obstacle, we should actually be able to click the button. Yeah. And it works. Let me click somewhere else to make sure. Yep. Clicking around like a fool. And only if I click here on the button, it actually resets the game. Let me switch back to regular mode, and it should still work. Yep, perfect. So yeah, there we go. We actually discovered a little bug here, but we fixed it, and now we should be good. Perfect. I just want to make sure here in the toggle display mode method that we actually use 1 for the z-scale so that it is unaffected, so that it doesn't ever change. I mean, multiplying it by 0, as you saw, doesn't really have a negative effect since the z-axis is not actually used. But yeah, setting it to 0, it seems like a wrong thing to do here, even though it technically doesn't make that much of a difference. But yeah, so make sure to set the z-scale here of the create scale. The z pass 1 for the z-scale parameter. All right, that was the final adjustment that I wanted to make here. Our game is finished. Feel free to adjust those values, such as the spawn rates, the speed of the T-Rex, the acceleration of the T-Rex, the maximum speed of the T-Rex, things like that, the minimum score that needs to be reached for the pterodactyls to spawn, things like that. Feel free to adjust those values so that it just feels right to you, so that the game is not too hard, not too easy, not unfair. I feel like I have not exactly chosen the optimal values there, but it seems to be okay, and it demonstrates, yeah, it does its job. It demonstrates how a thing like this can be achieved. And yeah, we're done here. We implemented the TrexRunner game from Chrome in MonoGame using .NET Core and C#. And it's a fully functioning game. You can reach a high score, which can be saved to the hard drive. We changed the icon. We even made it possible to zoom in so that everything is easier to see. And that's really all I wanted to do. Technically, we could use this game now as a basis for even further enhancements, like maybe we could implement a bot mode where the T-Rex is actually controlled by a bot, so that it doesn't actually respond to input, but instead it uses some sort of algorithm to determine when it should jump and stuff and when it should duck. We could do that, and if you want to see something like that, let me know. Just drop a comment and I'll consider it. There we go, back to daytime. Everything looks fine. And I feel like the spawn rate seems fair. Maybe I'm being too harsh. Yeah, I don't know. Okay, so thank you a lot for sticking by, and I hope you enjoyed this video series. Again, this format here is something that I would like to continue, so I don't have any script for this. Basically, very little preparation. It's just off the cuff. It's some sort of hybrid let's dev, let's code tutorial kind of format. And I really like that. I enjoy it. Let me know if you enjoy it too. And yeah, see you in the next video. And have fun. But hold on. DJ, bring the beat back one more time. Actually, I want to get into one more topic here, because it was requested by a viewer. And the question was, when I'm done with my game, how can I distribute it to my player base or to potential players? And of course, that's a huge topic. These days, there's so many platforms that help you distribute your game or your application. There's, of course, Steam, there's Itch, there is GameJolt, there's the Google App Store, the Play Store, I mean, the App Store for Apple, things like that. Just so many possibilities. And I just want to show you one way here. But first of all, right now, we only have a debug build of our game. We don't actually have a released version yet. So let me just go ahead and actually create a release build. And for that, the first thing I'm going to do is I'm going to right-click here on the project, properties, and there's a few things that you can set up here. And just to polish your game before you release it, I think it's a good idea to, yeah, make sure to set some of these values to, well, something that makes sense. First of all here, well, assembly name, default namespace, we're not gonna mess with that, that's fine. We did change the icon, but let's go into the package tab here, and that is mostly for NuGet packages, but it's also used in the metadata of your application. So package ID, I'm going to leave it as it is. The version is 1.0, that's fine. Authors. Well, the author is me, so I'm going to put Lucky Goodrich here. Sorry, I have to type with one hand right now. Company is my pseudo company, which hopefully at some point will be a real company. And the product is TrexRunner. That's fine, but I want to spell it properly. And we should be good. Description, yeah, you can put a description here if you like to. Copyright, no, I'm not gonna set a copyright here. That's fine. Here also make sure the icon is set to whatever you want it to be. Here I chose my icon that I created as a PNG file in this case. And that should be fine. I'm going to hit Control S to save. And now we can go ahead and say here, we're not going to use the debug configuration, but the release configuration. And then we can hit start, or we can hit build. Let's just hit here, build solution. And succeeded, that's fine. And now let's take a look at the result of our build. So here, if you go into the bin folder, you will find a release folder there. And there you can find your game. And now if I take a look at the metadata here of the application, for example, by just hovering over it, we'll say, well, it's in German here, but it says company, Yeti Byte, description, TrexRunner, version 1.0, and so on and so forth. If I right click here and go to details, here it also says product name. You know, it's a nice to have, but not required. So yeah, this is the finished build of our game. So what we can do now is simply, well, there are tools for creating installation wizards and stuff like that. But from my experience, it's these days people don't want to have to install games or applications. They just want to download them and use them right away. Preferably, they download them in like a zip or in a zip archive, unzip it, done. And so, if you'd like to use like an install wizard, just go to Google. There's plenty of tools for that. Yeah, we're just simply going to use a zip file to zip our released build here. And I have 7-zip installed for that. I'm sure most of you use that to deal with your zip files. So all I'm going to do now is select all these, right click 7-zip, add to, well, here it's called Net Core App 3.0 zip, but I'm just going to zip that and then rename this TrexRunner _ 1-0 or something like that. And then there's my game. And now I want to distribute it to players. Well, actually, I'm not going to actually go ahead and do that, but I'm going to show you a way that you can publish your game, one way to publish your game online so people can actually enjoy it. So one very easy way to get your game out there is the website itch.io. I'm pretty sure a lot of you guys are familiar with this platform. So yeah, you can just go ahead and create a free account. If you don't already have one, go here to register. And I think you can also just use your GitHub account. I'm pretty sure. Yeah, here. You can also register using your GitHub account if you have one. That's a pretty quick way to set up an account here. And yeah, once you have an account, you can then upload the game to your profile. So here's my profile. There's a game from a from a game jam that I once participated in, but never mind that. So yeah, then you can go ahead and go here and say upload new project. And then it's pretty self-explanatory, you know. Just type in the title of your game. This will be the URL for your game project. Yeah, you can add descriptions, taglines, whatever. Set this up so that people can easily find your project. Make it appealing. And then you can actually upload file. And in this case, I would of course upload the zip file that I just created. And then once I'm done, I just save it and publish the project to itch. That's one way to get your game out there. But like I said, these days it's really easy to get your games out in the public. The hard part is to make people notice it. Another thing that you can do if you use GitHub, you can create a release in your game's repository. So this is the repository of the TrexRunner game project. Here's the source code and all of that good stuff. And when I'm in this repository on GitHub, I can go and create a new release. And then I'm going to have to add a title here. I'm just going to enter let's just say V1.0. Choose a tag. The tag is going to be V1.0. The title is actually, let's say TrexRunner version 1.0. And I'm going to add a description really quick here. Hold on. There we go. This should be fine for now. And now I can upload the file. I'm just going to drag and drop it here, the zip file. There we go. It's going to take a while. And that should be it. And we should be good. We added a tag, version 1.0. Title is fine. Description seems to be fine as well. Let's click Publish Release. And there we go. And now we have an official release of our project. So if I go back to the repository here, in the releases section, we actually have version 1.0 available for download. So that's also a way to get your game out there if you're going the open source route. In this case, it's perfectly suitable. Yeah, so thanks again for watching. I hope you enjoyed this video series. We created a fully functioning game using the MonoGame framework and .NET Core with a C# programming language. And yeah, it was a pretty cool experience. I hope you enjoyed it. And I really hope to see you in my next video or video series. And remember that the full source code of the project is available at my GitHub. Just take a look at the description. There will be a link down there. See you guys.